Hi everyone, in this video I'd like to start adding to our list of special values. So the special values are angles or arc lengths that we are very comfortable with, and just knowing that angle or arc length is enough for us to identify the x and the y coordinates of the point that it points to. So I would say right now we already have some on that list. Any multiple of pi over 2 we should be able to find on the unit circle. And sorry, my dog's whining at me. Stop it. Stop it. Find on the unit circle and state its x and y coordinates. And we want to go a little further and get to the point where we can do any multiple of pi over 4 or pi over 6. So let's start with the pi over 4s. Okay, so first, the pi over 4s, okay, what do we know? We know that halfway around is pi. We know that a quarter of the way around is a pi over 2. So a pi over 4 puts you right smack in the middle of quadrant 1. And our goal is to be able to do not only pi over 4, but any multiple of pi over 4. So we want to be able to spot and know the coordinates for any of those 4 points. Notice pi over 4s actually hit all the quadrant angles as well. This is 2 pi over 4, so it's a pi over 4, 2 pi over 4s, which is a pi over 2, 3 pi over 4s, 4 pi over 4s is a pi, 5 pi over 4s, 6 pi over 4s is 3 pi over 2, 7 pi over 4, and then 8 pi over 4 is a 2 pi. So we want to be good with any of those, and also the negative versions, and we want to be able to go around more than once, and so on. Okay, so to work on the pi over 4s, we have to go back and do some triangle work. So we've been working with triangles a little bit, but there is one triangle fact we'll need in a little bit that I'll give to you. Otherwise, I would just say that if we're looking for the coordinates of this point right here, I'm going to switch pens. I'm trying to get this one to eke out a little more life, but I don't think it's going to work for me. Okay, so if we are looking for the x and y coordinate of this point right here, I think something really helpful to notice is that, more than one way to see it, if you're right smack in the middle of the quadrant, then your y and your x are the same. You're on the line y equals x, so your y and your x have to be the same. So if we go to our Pythagorean theorem and we say we know that x squared plus y squared always has to be 1 on the unit circle, and we also know that y and x are exactly the same, we can do a substitution. So either replace x with y or y with x. Doesn't matter which. I'll go ahead and replace y with x. And this turns it into a quadratic with only one variable, so we can definitely solve this. We want to combine like terms, so we have 2x squared equals 1. And we can divide by 2, so x squared is 1/2. And then we can square root both sides. So x is going to be equal to plus or minus the square root of 1/2. Again, I don't care about rationalizing denominators, but I do care about you taking the square roots of perfect squares, and 1 is a perfect square. So we're thinking this is the same as a root 1 over root 2, and the square root of 1 is just 1. So 1 over root 2 is wonderful. If you've had some trig before, it's very likely that you did get picked on about rationalizing denominators. So again, this is great practice, not mandatory for me for answers, but you can rationalize your denominator and get root 2 over 2, which may be more familiar to some of you. If not, I'd stick with the 1 over root 2. I actually like the way it behaves itself a little better when we're doing reciprocals. It's much nicer to work with. So we figured out that x is either positive or negative 1 over the square root of 2. If we go back to our picture, we were looking for the point in quadrant 1. So I'm going to choose the positive, positive 1 over root 2. And then we also want to know our y value, but that's really easy because we've decided that y and x have to be the same. So this point right here is 1 over root 2, 1 over root 2. Okay, so that is the point that's associated with an arc length or angle of pi over 4. from this, we should be able to use some symmetry, which we'll get into even more next section, but I think we can spot some here. If this is the, oh, here we go. If these are the coordinates for the point at the end of pi over 4, we should be able to also figure out the coordinates for the point at 3 pi over 4 because that is directly across the y-axis from our original point. So if we just take this little triangle and we flip it across, it's the exact same shape. We just now have a negative x with our positive y. So this is a negative 1 over root 2, 1 over root 2. Similarly, if we flip over here, we could start from either point. We could flip this one upside down, or we could take the original one and flip twice. This is going to be negative 1 over root 2. I didn't leave myself enough room. Negative 1 over root 2. And then the last one, we can flip directly across here, is a 1 over root 2, negative 1 over root 2. So those 4 points, which are at the end of infinitely many different arc lengths that are all multiples of pi over 4, we should be comfortable with. So this is your next memorization chunk. You need to memorize the special values. But what I would say is you really only need to memorize the points and arc lengths in quadrant 1 and then be able to use symmetry to find the points and arc lengths in the other quadrants. So this one right here, memorize. Pi over 4, 1 over root 2, 1 over root 2. Okay, so there's the first one. Second one, let's do a pi over 6. So this one up top was the pi over 4. I think I labeled it. It's okay. For pi over 6, we want to picture taking our pi and splitting it into 6. So we could even say we're going to take pi over 2 and split it into thirds. A third of pi over 2 is a pi over 6. So we're going to have, let's see if I can do it about right, 1, 2, 3 pi over 6s. And then we'll need a 4, 5, 6 pi over 6s. Okay, so this is the one we're going to start with right here. So this is my, let's make another color. This is my pi over 6, and I'm interested in the coordinates x, y. They're at the end of that pi over 6, so we have to do slightly fancier triangle work on this one. Okay, so let me draw this triangle a little bit bigger. This is the one that we need a little bit of triangle knowledge for, but not a lot, so I'll just give it to you. So we're imagining that this is a pi over 6, and this is our x, and this is our y, and we know that this is 1. So what we end up wanting to do, there's 2 things. Okay, so one is if we know that there's a right angle and we know that there's an angle of pi over 6, given 2 angles in a triangle, you can always find the third because the angles in a triangle have to add up to 180 degrees, which in radians is pi radians. Halfway around is 180 degrees, also known as pi radians. So we know, here I'm going to call this angle beta for now. We know that if we add up pi over 6 and beta, and the 90-degree angle is a pi over 2, right? Pi over 2 is a quarter of the way around. We should get pi. So we can work a little bit on solving this thing. I'm going to just do this one step at a time. So if I subtract off the pi over 2, that's a pi minus half a pi, which is half of a pi. You can get a common denominator. This is 2 pi over 2 minus 1 pi over 2, which is 1 pi over 2. And then we want to subtract off a pi over 6. So let's do 3 pi over 6 minus pi over 6, which is a 2 pi over 6 or a pi over 3. Okay, so this is a special triangle. And again, if you've done right triangle trig before, but not unit circle, you might be familiar with the 30, 60, 90. That's the one that we're looking at. So we know we have an angle of pi over 3 and we have an angle of pi over 6. What I want to do is double this triangle. So I'm going to attach an identical triangle underneath here. So now I have another pi over 6 down here, which means this thing is a wrong color. grand total of 2 pi over 6, which is pi over 3. So I have a pi over 3 up top. I have a pi over 3 on this side. My picture's not very good here. I have a pi over 3 at the bottom. So what I have is an equilateral triangle. This doesn't look like one much, but the 3 angles are equal and the 3 sides are also equal. So pretend like my 3 sides look equal, which means this is a 1, this is a 1, and this entire thing is a 1. But we didn't want to know what this entire thing was. We wanted to know what y was. So it looks like y is equal to 1/2. So for this point, we have a y coordinate of 1/2. We still need to find our x coordinate. But now we can go back to our original triangle and we can say, let's see, if this is a 1 and this is a 1/2, we should be able to use a Pythagorean theorem to find x. So x squared plus 1/2 squared, which is 1/4, equals 1, which means x squared is equal to 3/4, which means x is equal to plus or minus the square root of 3/4, which is the same as plus or minus the square root of 3 over 2. I do want you to do that step where you take the square root of 4. We were working on the point in quadrant 1, so that's going to have a positive x coordinate, so we'll pick the root 3 over 2. Okay, so this is the second trio to memorize. An arc length of pi over 6 lands you at the point root 3 over 2, 1/2. So, again, we should be able to get quite a few other points based on this. We'll get all of them, but I'm actually going to save up the 2 pi over 6, which is a pi over 3. And the 4 pi over 6, which is a 2 pi over 3, we'll save those for just a second. So I'm going to skip all the way over to the 5 pi over 6. So if we go from 1, 0 all the way around, that's 5 pi over 6 units. And that point is directly across from where we ended up at arc length pi over 6. So that's going to be a negative root 3 over 2, positive 1/2. There should be another one straight down from there. It's a 7 pi over 6. So 6 pi over 6 is pi. And then the next one, 7 pi over 6, is going to be at a negative root 3 over 2, negative 1/2. And then the last one, we're going to skip these bottom points. So there's 8 pi over 6, which reduces to 4 pi over 3. And then 9 pi over 6 is 3 pi over 2. 10 pi over 6 is 5 pi over 3. So we'll do the pi over 3s next. And then this last one is 11 pi over 6s, which is going to be the point root 3 over 2, negative 1/2. Okay, so again, our goal here is to be able to match up these 3 pieces of information. Arc length is how far around the outside of the circle you've gone, starting from 1, 0. And given an arc length, you can find the exact point that you're interested in. So an arc length uniquely determines a point on the circle. X and Y coordinates also uniquely define a point on the circle. So we want to be able to, given an arc length, given one of these special arc lengths, find the X and Y coordinates. Given X and Y coordinates, we should be able to identify the arc length. Given only an X or a Y, we should be able to work our way to finding the other things, but there's a little bit of ambiguity because if I just give you an X, there are 2 different Y values that go with every X, and the same thing if I just give you a Y. Okay, so let's see. One more. Let's see if I've got pen and paper handy. Okay, last one on this special value stuff. The pi over 3s. We don't actually end up having to do much work for them because if you'll recall, the triangle that we drew before had pi over 3s in it. So let's see. Can draw this nicely. Okay, so we wanted to picture taking our pi and dividing it by 3, so we get 1 up here, 2 over here, so 1 pi over 3, 2 pi over 3, 3 pi over 3 is equal to pi. So if we draw our triangle, it looks like this. So here's our X and here's our Y, and this is our pi over 3. So if I make that triangle a little bigger and investigate, I have a right angle, I have a pi over 3, I have a 1, an x, and a y. Okay, so from the last problem, I wish I put these on the same page, we ended up having this triangle when we were all done. It had a pi over 6 and a pi over 3 and a right angle. And we knew the hypotenuse was 1, and that across from the 1/6 we had 1/2, and across from the pi over 3 we had root 3 over 2. So back to this triangle we were just working on, through the exact same thinking as before, that the angles have to add up to pi, this has to be our pi over 6. So this is really the same triangle, just oriented differently. So it's like we flipped across. So what was our x has become our y. So the y part has to be the root 3 over 2. So straight across from the pi over 3 should be the root 3 over 2. So here's pi over 3, and straight across is root 3 over 2. And then straight across from the pi over 6, straight across from the pi over 6 should be the 1/2. So we don't actually have to go back and do the same work again. We get that the coordinates of this point are 1/2 root 3 over 2. Okay, so from this one, we can count out the pi over 3's. And again, the pi over 3's really can be considered pi over 6's. This is a 2 pi over 3. But I sort of like to think about them separately so I don't have to do quite as much reducing fractions. So here's a pi over 3. The next one is going to be a 2 pi over 3. And that will have coordinates negative 1/2 root 3 over 2. The next one's a 3 pi over 3, which of course we can find. It's negative 1, 0, but it doesn't relate back to this point directly. The next one is a 4 pi over 3. So that will have coordinates negative 1/2. Oh, I almost done with my purple pen too. Root 3 over 2. And then the very last one is 5 pi over 3. Oh, I didn't write this either. Here's a 4 pi over 3, a 5 pi over 3, and the 5 pi over 3 will have coordinates, oh, where's my negative? That last one was negative 1/2 negative root 3 over 2. 5 pi over 3 will be positive 1/2 negative root 3 over 2. Okay, so our goal is to be able to, given any multiple of pi over 4 or pi over 6, including the pi over 3's and the pi over 2's and the pi's, you should be able to figure out where you are on the unit circle and give exact x and y coordinates, or vice versa, given exact x and y coordinates that are special values. You should be able to work your way backwards and tell me an arc length, many arc lengths that would end at that point. There are always infinitely many. Okay, one last quick note here. So again, what I was saying is I don't want you to feel like you have to memorize the whole list of points that we walk through. What you should have memorized is just quadrant 1 stuff. So you should know that 0 or 2 pi will land you at 1, 0, and of course 4 pi and 6 pi and negative 4 pi and negative 6 pi. You should know that pi over 2 or any equivalent to that will land you at 0, 1. You should know that a pi over 4 will land you at 1 over root 2, 1 over root 2, or if you like the rationalized denominators, root 2 over 2. And you should know that a pi over 6 lands you at root 3 over 2, 1/2, and a pi over 3 lands you at 1/2 root 3 over 2. So there aren't actually that many numbers to remember. You can see if you're right in the middle, you've got to have that identical pair, 1 over root 2, 1 over root 2. And then the other two are just flip-flops of each other. I have a root 3 over 2 and a 1/2 in each pair. So personally, the way I keep track of which one I want is just by realizing that root 3 is bigger than 1. So root 3 over 2 is bigger than 1/2. If your x is bigger than your y, that means you're going to be down here below y equals x. So basically, x is the bigger one, is what I would say. Okay, I'm at pi over 6. That's right around here. My x is bigger than my y, so my x has to be the root 3 over 2. Whereas if I was at pi over 3, I would say I'm towards the top, my y is bigger than my x, so my y has to be root 3 over 2. And then from there, you should be able to flip across the x-axis or the y-axis or both and get all sorts of other points. All right, so those are our special values. Thanks for watching.